Welcome to Educare 247 guys. We are back with the CAT Concept Express series, concept number 5. And today we are going to cover some of the most important and prevalent concepts that come in CAT examination on trapezium. Alright, this is the most frequently ignored quadrilateral in all of geometry. And trust me, there are questions which will puzzle you and which have very easy solutions and unique solutions that we are going to give you over here. So let's get started with concept number 5 of our CAD Concept Express series. So let's suppose there's a quadrilateral ABCD such that this AB line is parallel to CD. Then we say that this is a trapezium. This quadrilateral is called as trapezium when the line AB is parallel to CD. What does this mean? What are the implications of AB parallel to CD? So angle A plus angle D will be equals to 180 degree, right? Because both the lines are parallel, so interior angle. Similarly, angle C plus angle B will be equals to 180 degree. And this line DE over here will be the height of your trapezium. Alright, it will play a very important role in a lot of properties. So for now, just understand what is a trapezium, how to identify a quadrilateral as a trapezium. That is the most important point over here. So now what we are going to do is, we are going to see some very important properties on trapezium that are useful for solving CAT level questions. Alright, so let's suppose again this is a trapezium A, B, C and D. Alright, so let that first diagonal be AC, right, and the second diagonal be BD, right? They are intersecting each other. So we have drawn the diagonals. Here neither AC is equals to BD nor they are bisecting each other. Alright, do not pre-assume these things. Alright, so we have drawn two diagonals for this trapezium. Now AB is parallel to CD since it's a trapezium. So definitely we can infer that if this is beta, this will also be beta. Alright, alternate angles in two parallel lines. Similarly, if this is alpha, this will also be alpha because of alternate angles between two parallel lines, right? So basically here triangle, let's suppose this is O, right? So OAB is similar to triangle ODC, right? And because of that we can say that OB upon OD is equals to OA upon OC. Now we do the cross multiplication. We have OB into OC is equals to OA into OD, and this is a very important property that you should always keep in mind with respect to a trapezium. If we need to remember this, how will you remember this? See, this is OB on this side, OC on this side, so diagonal on one side I have taken over here, OA on this side and OD on this side, right? OA and OD over here, so diagonal on the other side. So it's just a product of diagonals on one side is equals to the product of diagonals on the other side. Alright, diagonal means part of the diagonal, that is OC and OB form one part, we multiplied them. OD and OA form one part, we multiplied them. I hope you have understood this. Please keep this in mind. So let's suppose tomorrow you get a question that this is 15, alright, this is 8 and this is 12. So what is this? So this will be very easy for you. Many people will start deriving a lot of equations and similarity theorem and all that stuff. Just 15 into 8 is equals to this question mark into 12, and you'll get your answer as 4 2s are 4 3s are 3 1s are 3 5s are question mark is equals to 10. Hence 10 will come over here. Easy, right? Another very important property or formula you may call, I want you to know, and this is the most ignored formula, and trust me, questions have appeared on this in a lot of examination, is the sum of the square of diagonals, which states that AC square plus BD square, that is the square of the diagonals, is equals to AD square plus BC square plus 2 into AB into CD, right? So you can remember this as the square of this side, slant sides, alright, and addition of both the sides, right, individual squared, and 2 into this base parallel side, that is AB into CD. This is the basic formula. Alright, please keep this in mind. Questions do pop up on this formula very often. The next important, and I would press the word important because this theorem is not known to a lot of students and its importance in examinations is too high. Alright, midpoint segment theorem. This is applicable in trapezium. So suppose there is a trapezium ABCD where E and F are the midpoints of side AD and BC respectively. In this case, alright, in this case, the value of this EF, that is this mid segment, will be half of AB plus CD. Alright, so this line segment is equals to the sum of AB plus CD divided by 2, in short. Very important theorem. Alright, you have to keep this in mind, because a lot of time some questions where you have to use this particular theorem comes up, and if you are not aware about this midpoint segment theorem, you will be lost. You will be lost in pages and pages of long derivations that you have to do during the examination, which is not at all feasible. Alright, that is why knowing this theorem is so important. So let us have a look at this question. I have not taken the area, but I am going to introduce you to the area of trapezium over here. So ABCD is a trapezium in which BC is parallel to AD and BC is 16 centimeter while AD is 12 centimeter. Distance between the parallel line is 10 centimeter. Find the area. So basically the diagram would look something like this. Alright, so AB, C, D. So BC is parallel to AD. Also they have given that distance between this line is how much? 10 centimeter. BC is how much? 16 and AD is 12. Alright, complete AD. Okay. So in this case, whenever you are asked the area of trapezium ABCD, your formula will be half into sum of parallel sides into the height, that is the distance between the two parallel sides. So here it will be half into 16 plus 12 into 10. Alright, so 2 1s are 2 5s are. What is 16 plus 12? It is 28. So 28 5s are. You will have 140 centimeter square as your answer and the area of the trapezium. As simple as that. Let us have a look at this question. ABCD is a trapezium where AD is parallel to BC. Diagonal AC and BC intersect each other at O. AO is equals to 3 units, CO is equals to Y minus 3 units, BO is equals to 3Y minus 19 units, and DO is equals to Y minus 5 units. Find the value of Y. So actually this is supposed to be a very high level question in terms of its difficulty level. But we know the shortcut for this, right? We have already studied the formula for this, the theorem for this, right? So let's suppose this is one diagonal, alright, and this is another diagonal, alright. So they are intersecting each other at O. Okay, so what do we have over here? We have A, B, C and D, right? And they are intersecting at O, right? And what else has been given to us? We have been given AO is 3 units. Alright, what is BO? BO is 3Y minus 19 units. And what is DO? DO is Y minus 5 units. And last CO is Y minus 3 units. So I had given you a formula, if you remember. So AO into BO should be equals to OD into OC, right? So just take down it over here. What is it? 3 into 3Y minus 19 is equals to Y minus 5 into Y minus 3. Just expand this. After expanding this, you will get 9Y minus 57 is equals to Y square minus, it will be 8x over here, 8y over here, sorry, plus 15, right? So when you solve this by taking all of this on the right hand side, you will get your final equation as y square minus 17y plus 72 is equals to 0, right? So if you solve this, you will get y minus 9 and y minus 8 is equals to 0. So y is either equals to 8 or 9, right? So can both be the values of this trapezium? Yes, they can be. The only condition is that no length should be negative. So just put 8 and 9 in all the equations that are there and check whether they are negative. I do not think so they will be negative, and hence there will be two values for y, which will be 8 and 9. Alright, the major takeaway from this question is this formula that you should understand. Let us have a look at the next question. ABCD is a trapezium in which AD is parallel to BC. AB is equals to 9, BC is equals to 12, and CD is equals to 15, while DA is equals to 20. Find the sum of the squares of the diagonal. So now you will be able to connect the formula that I had given you for the sum of the squares of diagonal, right? So let's suppose this is a diagonal. So this is the trapezium. All right, so let's suppose this A, B, C, D. All right, and this will be the diagonals. So what have they asked? They have asked you the sum of the square of diagonals. We have seen the formula for this. So what have they asked? They have asked AC square plus BD square, and we know what is the formula for this. It is AB square plus CD square plus 2 into the multiplication of the parallel sides BC into AD, right? So just input the values. What is AB over here? AB we know is 9, BC we know is 12, and DA we know is 20, while CD is 15. So just input the values now. So AB 9 square plus CD, which is where is CD, 15 square, plus 2 into BC, which is 12, into AD, which is 20. So when you add all of this, you will get 786 as your answer. All right, 786 units, whatever it is. So the application is quite extensive of this formula, but very little known to students. All right, so that's it in this CAT Concept Express series, concept number 5. I hope you have enjoyed this. Thank you and happy learning.